Welcome, ladies and gentlemen, to the SuperDataScience Podcast. Today I've got a special episode with Risto Miikkulainen from Sentient AI. Welcome, Risto, and thank you so much for joining on such short notice.
Thank you. Happy to be here.
So tell us a bit, where are you calling from? It was such a surprise. I was expecting you're in San Francisco, and you're completely on the other side of the world.
Yeah, today I'm in Helsinki, Finland. The weather is just nice here and the sun doesn't go down. So you get a lot of work done.
Yeah, that's fantastic. I heard like at this time of the year, it's still sunny at midnight.
Yeah, it is kind of a little dusk, but it comes up right at 2 a.m. again. So it's hard to get any sleep.
That's so cool. Yeah, and it was interesting as well. At the start, we had a quick chat about your background. You come from, or you were a professor at the University of Texas. Is that right?
Yes, I am actually. I'm on leave. Have been on leave for a while. I'm at UT Austin in the computer science department there.
Okay, cool. And give us a bit of like a rundown, if you don't mind, about the work that you do at Sentient, and what is Sentient all about?
Yeah, sure. Sentient is one of the best funded startups currently in artificial intelligence. And we started with stock trading and have added intelligent commerce and digital media to that. We build products that are based on cutting edge artificial intelligence, in particular, deep learning and evolutionary computation. So that is machine learning that not only predicts, but also optimizes what you're doing in the internet or in the stock market.
Okay, and I had a quick chat to Babak, who is the CEO, as I understand, of Sentient AI, and he gave me a quick overview of the 3 products that you have. Could you talk a bit more about them, those the current 3 products that you offer?
Yeah, sure. So the trading product is what you might expect. It's stock trading. We evolve using genetic algorithms stock traders that are completely autonomous. I mean, it takes a long time to evolve them. We built actually a whole grid computer-like system where we evolved these traders for several years. 40 trillion of them were tested in this process over 1 year, and some good ones were found. And these traders are sets of rules that tell the system how to trade stocks. They observe the time series and then they make trading decisions on their own. And in this way, they are completely autonomous. We, of course, monitor them and make sure that they are not getting out of their league, but that very rarely happens. They actually have been trained and tested so well that when we actually deploy them, they do quite well. So that's stock trading. The second product is intelligent commerce. The idea there is to build an interface to retail, for instance, some kind of e-commerce site where there's lots of items in the catalog, and the users, the customers, would like to see them. They would like to be able to navigate that space of all possible products conveniently, not by using keywords, having to guess what keywords are relevant, but by looking at the product and saying, oh, I like something like this, I like something like that, and the AI will figure out what it is that you want. For instance, if you are buying sunglasses or shoes or other apparel, you get a window that shows you what kind of shoes there might be, and then you can click on those that are more to your liking, and you get another sampling. And this way, after a couple of clicks, you usually find what you're looking for. And the beauty of that is that in a normal keyword kind of search, the customers might see 15% of the catalog, typically in a week. 15% of the catalog is shown to the users. Using this kind of search, which is based on users' input and feedback, 70% of the catalog is actually shown, which is much better for the vendor, it's better for the user, for the manufacturer of shoes, they get more visibility. So this is an intelligent interface. It is based on users' feedback in a loop. The AI figures out what it is that you're looking for. That's the second product, that's Sentient Aware. And the third one is Sentient Ascend, which is in the digital media space. It means that, for instance, we are optimizing web interfaces. So again, in an e-commerce site, it's a very important concept. What the landing page, how good a landing page is. Is it going to convert the user to a paying customer or somebody who signs up for the membership or something like that? There might be a goal for this website to convert a user into something. And it turns out it's actually quite hard and quite difficult and And it's a whole art of its own how to design the web page so that this will happen. And there are general principles of design, of course, like you would have colors that are consistent. You should be clear where the action is, and but also things that are harder to understand, like how do we relate to the user, what kind of images to show, what is a good call to action, and so on. And there's a whole discipline called conversion science that has emerged that tries to uncover these principles.
Yeah.
Now, it turns out humans can do pretty good job, but if we let AI do the design, we can do quite a bit more. Okay. Human design is only possible, you can only think of a couple of designs and test them and evaluate them. But if you let AI do the design, in particular evolutionary algorithms, you can test a lot more, and you can test combinations, and you can make decisions quicker and find pages that convert that humans would not come up with very easily. So, for instance, one of the sites that we built, we only optimized the widget, which was the call to action and a button. And they called it the ugly widget because the colors were very flashy, and it turned out that was what the users wanted. They wanted to see where the conversion was, and they clicked 43% more often using that widget than the human designed widget. And this can be extended to many other things, but that's a great example of sentient descent, this kind of digital media optimization using evolutionary algorithms. So evolution is doing the design, not humans. So those are the current 3 products. Yes.
Very interesting. Reminds me of that situation they had with, remember AlphaGo beat the world champion of Go last year in South Korea, and like it had a few moves where it was putting the pieces not on the first, second, or third line, but on the 4th line, and nobody ever has done that in the past 3,000 years of the history of Go. And now this has revolutionized the whole, everybody is now thinking and analyzing that. And because it led the computer to win, so everybody's like, whoa, maybe we should do that as humans. That's really...
Yeah, that's exactly right. The computer, the AI does not care. It does not have the same prejudices as humans do. It plays very cool Go, and it makes very cool optimization. I got to tell you another story. In addition to those 3 products, we of course have various proof of concept projects going on. And some of them are not even immediately products. They are something that are just cool to do. So one of them is cyber agriculture, which we are doing with MIT Media Lab, Caleb Harbour's lab, and Phenome, their for-profit arm. This is a very interesting project. The idea is that they can build containers where you can grow plants, all kinds of plants, food, maybe fibers, maybe medicines, and you completely control what's in there. Temperature, water, light, nutrients, everything is controlled. Now, vertical farming has existed for a while, but what if you can completely control everything? Turns out nobody knows what to do. There are some rules of thumb. You should have sufficient water, for instance, sufficient light, but how do you really optimize the growth? So we let the same kind of evolutionary algorithm figure this out, and we were in a loop. So they planted what our algorithm suggested, and 3 weeks later we get basil that's grown according to that recipe. And it turned out that we discovered some things that were already known. AI discovered that.
Yeah.
For instance, if you try to optimize the size of the basil plant, you kind of lose on flavor. But if you try to optimize the flavor, you get smaller plants.
Interesting.
That's kind of what you expect. Strawberries, tomatoes, I like that. But the more interesting thing was that we were optimizing the light, the kinds of light, how much light, how long the light period was during the day. And nobody really thought of, exactly like you suggested, nobody thought that the plants would thrive if there was full daylight all the time. Everybody expected that 8 hours of night is necessary. Turn light off for 8 hours. Well, the algorithm very quickly discovered, no, you turn on the light and it's on 24 hours and the basil grows much better. So this is something that people did not anticipate, but the AI discovered it again very quickly. So yes, these kinds of opportunities exist now, especially for the algorithms that discover solutions, don't just imitate and mimic and predict data as it exists, but they have an opportunity to be in an exploratory mode. They try out things, and then we can use predictors to see what actually might come up, and they can optimize and discover things that we don't already know.
Mm-hmm. No, that's very, very cool. And I just actually yesterday read a quote by Mark Cuban. The Mark Cuban is on Shark Tank in the US, and he said that the world's first trillionaires are going to be AI entrepreneurs in AI startups. And sounds like you guys are right on track for that, right?
Well, that's the plan, definitely. Well, AI is everywhere, and it will be everywhere. So currently, a lot of the excitement is really in the algorithms and methods, but it's time now to build real products, things that people use. And the techniques are powerful enough. For instance, this website optimization that I mentioned, we have now consistently applied it to many, many customer sites, and consistently they beat human design routinely.
Nice.
And this is now in a real world application where there are real users who are not AI experts, but are actual users who want to buy something or want to sign up for something. And this is what's really exciting to me. We've had in the Evolutionary Algorithms Conference, Gecko, for a long time, there's a competition called Human Competitive Results Competition. And for many, many years, people have shown that evolutionary algorithms can discover these things that we don't know how to do as well. But this is the first time, to my knowledge, that it's actually out there beating human design over and over again every time it's applied. So that's really exciting. And yes, you know, the sky's the limit if you have that kind of a tool. And it still requires human ingenuity in identifying the problems and giving evolution enough space to work where to explore. So we have to think about that. But, you know, that's the kind of jobs that will be created is to work with the AI systems that create new things. You give them the problems and give them the parameters and give them the tools, and the AI will then discover, given that space, something really good.
Okay, no, that's fantastic. And you mentioned a couple of times evolutionary algorithms, whereas something that we have already talked about in the courses that I teach with Adlan de Ponteves is reinforcement learning algorithms, which are also AI. So as I understand, those are two different types of artificial intelligence. Could you comment on that for our listeners to just give a quick overview of what's the difference between the two?
Yes, absolutely. AI is a very broad area. There are many methods. And even machine learning has many methods in it. Most of the machine learning that you see currently is based on supervised learning, which means that you have a data set. This was the situation and this is what happened. It allows you to predict given the ground truth, like weather prediction, for instance. You know what happened the next day and you can learn to predict that. Now, reinforcement learning and evolutionary algorithms are a little different in that you don't know what the right action is. You have to explore and find that action yourself. The algorithm has to do that. So in that sense, reinforcement learning and evolutionary algorithms are in the same category, not in the supervised learning category, but in a reinforcement learning discovery exploration category. So what it requires is some kind of a system where the algorithm can explore. It can try out things and see how well they turn out. You don't know what they should do, what move they should play in Go, or what trades to make in stock trading. But you can tell after a while how well they are doing, how often you win in Go, how much money you make in stock market. That's the feedback. It's not the optimal action. It's just tell you how good your actions were you tried. And then you explore many different actions. Now, in reinforcement learning, the approach is to evaluate values for the actions in different states and then try to interpolate between those actions that you've seen. In evolutionary algorithm, you are evolving the entire system at once. You are testing it at once. You are not assigning values to individual actions. And in that sense, they're a little different. And what happens then is that reinforcement learning is perhaps best suited for learning over the lifetime of the agent. When you're learning while you're performing, and it counts what you're doing. In evolutionary algorithms, they are better in discovering good final designs when you can explore very broadly and spend a lot of time and effort into exploring avenues that might be more wild, perhaps, and there's not big cost for it. So, for instance, if you have a robot that you have to has to learn in real life, in a physical system, you might want to use reinforcement learning. If you have a simulator for that robot, you can learn in simulation and you can try things that you would not try in a real robot. And in the end, evolution can then discover in the simulation something that can be done on the robot and works really well. So there's a little bit different questions, but they are both examples of this kind of learning where exploration is the key.
Okay, gotcha. Very, very, very interesting. And if somebody was new to AI and wanted to get started into this space and completely new to AI, even new to machine learning, where would you recommend for that person to get started?
Oh yeah, okay. So this is very interesting. It used to be that you could pick up a textbook that was written a couple of years ago and be pretty much up to date, maybe look at a few journal papers, and that has changed. And now the field moves very, very fast. 3 months is a long time now in AI. And it's a bit of a problem. It's very hard to keep up with that. But there's no question you have to know the fundamentals first. And there are certainly textbook and books that do that. Right now, perhaps the most productive, hottest area is machine learning. So we might want to pick up a book that's about machine learning as opposed to more broadly in AI. But there's much that the rest of AI has also to offer, including various reasoning systems and logic representation. And I believe strongly that this machine learning that has been very powerful in the last couple of years is going to stay powerful. But eventually we need to connect what is being learned with these reasoning systems. So that will also be part of it. And if you want to know where the future is going, learn about machine learning, but also learn more broadly in AI. And there are excellent textbooks in both of those areas. Now, if you really want to do the latest, then you have to go to the web. You have to look at archive. You have to look at blog posts. And there are some really good ones. It turns out that sometimes the latest papers are very technical, kind of hard to follow, hard to see the picture. But it turns out there's also a whole another community, people who write these blogs that describe what these inventions in these papers actually are about and put them in perspective. And sometimes you can find those, they are mostly tutorials, perhaps. Tutorial on generative adversarial networks, for instance, a tutorial on probabilistic soft logic, various aspects, tutorial on evolutionary computation or neuroevolution. And those are then, after reading the textbooks, pick up some of those tutorials and you can pretty much catch up with relatively easy. But the field is very broad. So don't assume that you can catch up with everything immediately. That takes years, but certainly catch up with so that you can read the literature and understand what the excitement is about.
Okay, gotcha. And I totally understand. And I actually agree with that. It's incredible what we've seen. Like when we were doing the AI course, which we're creating now, there's been so many changes even while we're creating the videos. You just have to keep up with things. And I recently heard an opinion that AI is not only going to get more sophisticated and more powerful in the challenges that it solve, but it'll also get more accessible to people. It'll become more kind of drag and drop. There'll be more tools for people to use AI. Not the most cutting edge AI, but over time things will become more accessible to everybody, even people who don't want to pursue the technical side of things. And with that in mind, the people who have like philosophy majors, who have the capacity for critical thinking, who have creativity, are going to start to see we're going to see an uptake in AI among those people. Would you agree with that, or do you have a different opinion?
Absolutely agree with that. And tools are very important. And there's now this is a big part of why AI is now moving at the speed that it's moving, and so many people are getting into it, because there are tools that people share, including software packages like TensorFlow, for instance. And it's open source, so people can also contribute to that, and people have. So in that sense, you can take TensorFlow, for instance, and download a model and run it and see what it's doing within a couple of hours. And then you can maybe build your own data set and apply the same model to your data set. And it won't take that much work to do that. And you might already be doing quite well. If you're a retailer, if you have some medical data, whatever it is, you can build a model very quickly. You still have to understand what its limitations are. I mean, it's too easy to attribute a lot of intelligence into what's happening. And you have to understand what it can and cannot do. And therefore, you should read those textbooks and understand it. But then actually running an experiment has become much, much easier. It used to be that my PhD students would have to take about a year to build the software and before they could run a really good experiment. And this is not true at all. Same is true of robotics. Now there are all kinds of robotics kits and hardware that's available, and you can get started. And that's how robotics is also accelerating rapidly. So yes, I totally agree. This is the best time, and we need those philosophers, and we need the psychologists, and we need the medical people. That's how we push AI forward. The applications are always exciting, and more people get into the field. And when new applications come out, there's always challenges. And then us who develop the algorithms will have to look at it and see how can we improve the method to actually make this work. So I think it's exciting. I've never in my career, 30 years I've been working in AI, it's never been like this, that we are so close to applications. We are working with people who have the original data. They see the patients, or they collect the statistical data from the customers, and we can talk to them, and we are immediately in the thick of things. And this is, I think, the most exciting thing about this cycle of AI hype, that it feels different because it involves a much broader base of people, both the academics, people who develop algorithms, and those who apply them, and those who use them and benefit from them. So I think that this is going to stay a little longer. We absolutely need the people from outside who are not AI experts to use these tools and do what they can.
Okay, fantastic. No, that's very interesting. And what are your thoughts on the other side of the spectrum? So lots more people are going to have access to AI, and we want more people to use AI. But what about the people whose jobs are threatened by AI? Like I don't know, chartered public accountants seem to be getting like slowly edged out by AI. Even truck drivers and slowly car drivers and so on. So there's going to be lots of change in the world. And I know this is a very philosophical question, and there's no one correct answer to it. But I just wanted to get your opinion on it, being a person who is driving this change in the world. What are your thoughts on that?
Yes, that's a very important question, and there's no question that it will require a change in society and in jobs. And this is a discussion that has to go on alongside with these innovations. And we cannot really have an immediate answer to any of these issues. Now, one important realization is that we're not going to have AI replace people completely in all areas. It's for a long time, they're going to be assistants. They're going to be making the job of the humans easier and more productive for quite a while. That's what we developed the AI to do. And it's, even if you take, for instance, self-driving cars, they're going to have to work with people for quite a while and on people's terms. Same thing in all kinds of medical decision-making, stock trading. We have autonomous stock traders, but we always watching over their shoulder, and they are, and we decide where to deploy them, what markets, and so on. So at least for the foreseeable future, they are just simply better tools for people who are working in these areas. But in a longer period, there will be a change that we don't need humans to make those low-level decisions, the actual decisions anymore, or driving necessarily the actual cars. We need people to plan where the cars should go, and what, like I said, markets to trade. So there will be a little bit of a change. Those jobs that are doing the nitty-gritty actions will be raised a little bit higher so that they can utilize the AI to be more productive. And there will be entirely new areas of jobs as well, because, for instance, cyber agriculture. That means that we will grow plants anywhere. They can be grown underground, on the roof, in the subway, and there will be jobs and markets and maintaining in this kind of distributed agriculture system. So that's what makes it interesting. It's kind of hard to imagine what the jobs will be like. And it's very difficult to imagine whether it will happen so quickly that there will be a displacement of people who used to do the old jobs, and it's very difficult to learn new jobs. Or it will be slow enough that they will gradually be phased out and new people trained to new jobs. This is a discussion that's ongoing, and we continuously have panels and discussions, the government leading some of those. There's publicity events on these, and I think it's an important discussion. But my perspective, if you really ask my personal perspective, is that I believe that there will be a slow change where people are always working with the AI and gradually learning to become more effective because they use AI as tools. And in the end, we will be better off.
Okay, gotcha, understand. And so the future doesn't look as bad as a lot of people are portraying it. There's hope, basically.
Well,
for the human.
there's definitely hope. Humans are very resourceful, and we'll figure out how to take advantage of this new tool, just like we've taken advantage of all the other tools, electricity, steam engines, all those things. They all caused transitional periods that were sometimes more difficult, sometimes easier, but we emerged better off in all those cases.
Gotcha. And any thoughts on the universal basic income, the UBI that's been pilot tested?
That's getting a little bit outside my expertise. Now, it would be interesting if people could be motivated to do something good with their time, which there should be plenty of, rather than maybe just watch TV, but be more creative or travel or. But I think a universal basic income only works if there's something to keep people busy and engaged and interested and motivated. And that piece is kind of interesting how that might happen. And it might require cultural change, but certainly something we should research more.
Okay, gotcha. Well, thank you very much for the overview. I know we went a bit to the side. I'd like to pull back into Sentient AI. Could you give us a quick overview of the team? Like, how big is the team? I remember Babak told me that you guys have been around for a long time, for 10 years or so. Like, you're coming up to your 10th anniversary.
Yes, that's right. This year. The beginning was the trading system. And this is a great first application because it requires nothing. You just have to have money and algorithm, and you can do it. You don't need to have support people. You don't need to build anything. It's a very good way to get started. Totally the opposite end is this e-commerce. You have to have, you have customers, you have users, you have to have web optimization, databases, cloud, everything. So it really takes a village. It's a huge team, and not all of those are AI researchers, obviously. Big computation is risk. So we had to build a grid computer system to just run these algorithms, 40 trillion traders. And now we are running these deep learning networks that we are evolving. They run on 5,000 GPUs, similarly in a grid, which makes that computer I think the 6th most powerful computer in the world, because those GPUs have so much power when you put them together. So there's a dozen people working on a compute, and then there's another dozen maybe doing the core research underlying the algorithms, and then maybe double that, 25 or so, who are doing the development based on those algorithms. How do you build applications based on that, new features in the products? And then our product development teams, maybe about the same size. And on top of that, you need to have customer support. You need to have salespeople. And this is something that we are kind of different from many AI companies, that we have real products and we have real salespeople instead of just generating the technology, cool demos. They are actual products, and therefore you have to have a very large sales force as well, and marketing and PR and so on. And this is how maybe trillion-dollar companies come about, that you have to have a well-rounded team. So, but interesting enough that the algorithm development is a relatively small team. I mean, like I said, 12 people. The algorithms are powerful, but and you have to have powerful algorithms, but then to build a product is 10 times harder. And this is what I've learned coming from academia. Having great ideas, having published papers, algorithms demonstrating their work, that's 1/10 of the job. That's when this real work begins. And I'm really grateful to be able to be in a company that has those other facets also covered, and a team that works together to achieve those goals.
Very, very cool. And you guys seem to develop products mostly for like B2B, and then these businesses then apply them to make the world better and maybe serve customers. Have you ever thought of getting into the B2C space and creating products directly for the end consumer?
Right. Yeah, that's a good question. That's maybe sometime in the future, if these techniques, if we find an application to those. Right now, I think um, that's a little bit different space. What might be an application of that? Well, for instance, you could do optimization for individuals, for their calendar, maybe for their navigation. There are perhaps some such tasks that these techniques could be applied to. But it is easier, like I said, to start with stock trading because you'll need customers. And here we have B2B, which a major investment can be done that way, and gradually build up and achieve more of those kinds of knowledge and know-how. But eventually, I think when people get more comfortable with having AI doing discovery for them, I think those applications should also come out. And that's probably still a couple of years out.
Okay, gotcha. Well, I'm a bit cautious of your time. I know you're a busy man. You have to run somewhere just very soon. I just wanted to ask you quickly, if somebody wants to get to know more about Sentient AI and get to learn about the company, are you guys open to having those conversations? Are you possibly hiring at the moment? Or what are the best steps that somebody who's interested in AI could take to get more involved with Sentient?
Yeah, Sentient in particular, yes, we have a website like everybody, and there's a blog that describes various things that are going on, and especially some of these algorithms and methods. And yeah, we're always hiring. Everybody always is, but there's also sentient.ai/careers list of currently open positions, and we are growing, and we'll grow in the future. So I would suggest first take a look at what we have there. We have also papers. If you're really technical, we have technical papers and published in Gecko and other conferences, and those are the real core algorithms. But also the blog posts give you a general idea of what's going on. For instance, with the cyber ag, publication is still a cycle. They always take a long time to come out. The blog posts are a little faster, and a lot of times those job announcements are tied to what's happening right now. So the blog post might give you a better idea. But yeah, that's and if there's no job today there that looks a good match, come back tomorrow. There might be.
Totally agree. Well, thank you so much for coming on the show. I know this was a quick episode, but it was short notice, and really appreciate you sharing the insights. Hopefully, Sentient will cover off like some really cool applications in the future, and we'll hear about the first $1 trillion company very soon.
We're definitely working on it. Thanks a lot for having me.
Okay, have a good day. Bye.
You too. Bye.